Hello, and welcome to the first week of print reading for construction. If you haven't done so already, please make sure you've reviewed the course syllabus, viewed the welcome video, and completed the check-in assignment. If you've done all that, you're good to go. Alright, so let's get started with our first lecture of the semester. So, the learning objectives and aspects we will cover in this lecture are: explain why drawings are important in the construction industry. We'll identify what is included in a set of construction drawings. We'll describe how drawings and prints are made. And we'll also discuss how to handle prints properly. So normally, when we would all be in a classroom together, and the idea of people sitting close to one another didn't cause a minor panic attack, I would have you all do this activity for the first day. Now, since we can't do this exercise together, I think there's still something valuable to share by explaining it. So the activity would begin with you all breaking up into groups, and I would hand you all similar types of items to build something out of. After you had your design complete, I would hand out some graph paper, some pencils, and rulers, and ask you to make drawings of the thing you just made. Ideally, you would want to make drawings to scale and try to replicate all of the dimensions and views of the design you made. Once the timer rang, you would then be asked to disassemble your design, which usually causes a little heartbreak from those who are quite proud of their design. And then I have you move to another group's table, and you'll use their plans that they drew to recreate their design. This is the part when you realize just how important a good set of drawings can be. Some groups do a good job of recreating the design from the plans, and others not so much. We then share how everyone did and compare the results with the pictures I took before the groups disassembled their first designs. So, the reason for this activity is to explain the utmost importance of why a detailed and comprehensive set of construction drawings is needed to complete any type of project. You might be asking, what was the material given to the groups? Legos. For those of you who are parents and have little ones in your life, you may not have as fond of a reaction to these little pieces of plastic as those who may remember these from their childhood. I'm sure many of the parents out there have suffered the immense pain these things can cause when you step on them. But all that aside, these work as a great material that can explain the multitudes of materials the average construction job deals with. So to go back to the activity, you can see how a group who had a great set of plans could put together something as architectural and modern as this image, and those who only maybe got half-complete plans and nothing else would maybe end up with something like this. As funny as this image may be, an incomplete set of plans can cause major headaches on a job site for everyone involved, including the contractors, project managers, the clients, and even the building inspector. You might be thinking, well, that doesn't really exist in the real world, right? Well, let's take a look at the Disney Concert Hall here in LA. It's designed by the famous architect Frank Gehry. He's known for his iconic style of curved, irregular panels that wrap themselves organically around a building, creating a very unconventional type of design. One other thing Gehry is also known for is how he starts the design process. A sketch. This is one of his sketches of the design that he would hand off to his firm of designers and drafters to make his sketch come to life. Can you imagine getting a sketch like that and find a way to turn it into the architecture of the image below? It takes a lot of talent and ingenuity to accomplish that feat in my mind. But even projects that start with a sketch like that are not how buildings get built. As informative and helpful as Gehry's sketch may be, it still requires plans like this one here, mapping out the layout of the space inside. Looking at this drawing alone, you can start to make out rooms and the spatial organization of the concert hall. And those whimsical curves on the outside are a whole lot more straight and traditional on the inside. And drawings like this one give us the unique perspective of the design, even giving us a sense of location by the inclusion of the adjacent streets. Here we can begin to imagine how the final product will look, and start to investigate what materials will be used to cover the building. And speaking of those coverings, detailed drawings like these give the observer a clear sense of how those curves come to life. A series of structural lattices that connect the curving metal panels back to the structural steel members that form the larger structure as a whole. So this question here, I think, is now relatively easy to answer. Construction drawings communicate the architectural and engineering design of the project. That key word is communicate. Construction drawings in and of themselves are a type of language that speaks to the person looking at them and tells them how this gets built. However, if you don't know that language, the language in this case being the symbols, abbreviations, line weights, organization, types of drawings, scale and dimensions, it's not going to make any sense. So let's start to understand this language. First thing to get out of the way is you'll hear construction documents called many different things. Blueprints, plans, prints, working drawings, they all mean the same thing. Depending on who you might be talking to, they'll refer to them differently. If you think back to the drawings we looked at in the previous slides, there are many types of drawings out there. The first one we'll talk about is orthographic. Orthographic drawings is the name that defines a majority of construction documents that architects and engineers make. These projections, as they are called, are different views of the object we're building. Front, back, right, left, and top would give you all the exterior views of your object. The next three all kind of fit into the same category, and that is perspective. These are the views you'll notice a lot in renders and sometimes in plumbing riser diagrams to show the entire system of a building and how it's laid out. The thing to take away from these drawings is this. Just like how one person may see things one way, another person may see things completely different based on their perspective. So as we look at this rendering, also known as a pictorial drawing, this may be one of the most deceiving types of drawings out there. Even though you can see a lot of detail and you may get a sense of how the building may look in its final stage, the one thing you'll never get from this drawing is precise measurement or dimension. You also won't get that from perspective, isometric, or axonometric. The only one that does, and it's the reason why architects and engineers use them, is orthographic. You can see here how orthographic drawings are true to life. The size of each elevation will be the same exact sizing on the drawings. Speaking of elevations, they complete views of each side of the building, indicating heights, access points, and material choices for the exterior. They also give us clues about sections too, and we'll get to that in a bit. Sections are views of interiors drawn from a specific point in the building. There are two major types. The first one is transverse, which is a section through a narrow width of a building, and longitudinal, which is a section through a wider part. Let's take a deeper look at those types of drawings, all of which are still orthographic drawings. Here we've got an old set of plans of a covered bridge in Wisconsin. It's a very descriptive name. It was built in 1876, and these plans are from the Historic American Buildings Survey and were found in the Library of Congress. Now, back then, drawing sets were not as in-depth as they are now. If you look at the bottom right corner of the title box, you'll see it say sheets 1 through 2, meaning that there are only 2 pages needed to build this entire bridge. Let's take a look and see if that seems possible. On the first page, we've got one elevation, the west one, and a plan view, also known as a top view. Notice we only have 2 dimensions given to us, the length of the bridge and its width. We also have a north arrow indicating its orientation, and a scale in the left bottom corner. That's about it here. Let's take a look on the next page because there's a lot left out here. Alright, that's a little bit better. We've got a floor and roof plan, an end elevation, and some details of the connection pieces of the bridge. And right in the middle is the legend. The legend will indicate in most cases the material selection, symbols and abbreviations, sizing of materials, and other verbal instructions of how this project gets built. Notice also the two section drawings. We've got the transverse section in red and the longitudinal one in blue. We've got some more dimensions included here too, the height of the bridge, and some info on the materials used. So if we go back to the first page and look at our plan view, we can see what the difference of those sections are doing. When you hear or see a section on a set of plans, what they really mean is if you slice the project at a particular point, and in a lot of cases that's right down the middle, the section drawing will show you what the inside of that part looks like. Imagine cutting into a piece of cake and it exposes all the layers and the type of cake that it is. It's something you can't determine from the exterior alone. So let's take a look back at that elevation drawing again. Those marks I've made are highlighting lines with arrows and letters and numbers. There's a lot of information from these otherwise random assortment. Each of those dark blue lines indicate where the section cut is being made, and the arrows indicate which way the drawing is looking towards. And those numbers and letters will tell you which page to find that section drawing on. This is a quick lesson on how understanding the layout and language of construction drawings helps you understand more details about the drawings and how to navigate through an entire set of plans. Let's talk about renderings now. Renderings are the flashy images that get a lot of attention from the clients and those who don't really know how to read plans. It's eye candy, and it sells the viewer on a utopian and ideal world where the building will shine brighter than any other building out there, and everyone you see in this image is happy and loving life. However, like I mentioned previously, the renderings are also a lie. They don't tell us anything that's actually helpful for the construction of the building and how it comes together. It's great for convincing financial backers to invest in your project, but not for the contractor who has to actually build it. One of the first discussions we'll have is this. Be sure to check that section of our Canvas shell for more information. Let's take a look at some other rendering examples now. As you see through these next few slides, the renders versus the reality of the products don't exactly match up. So let's talk more about how construction documents are organized. Generally, in smaller size projects, they can contain a lot of information on just a couple of sheets. But for large commercial projects, you'll end up with a set with usually hundreds of pages worth. So now we'll go through a rundown of some of the abbreviations used to describe different types of drawings. G for general, A for architectural, C for civil, S for structural, P is for plumbing, M is mechanical, E for electrical, and the only curveball here is Z for contractor and shop drawings. The ones in bold are the most common ones you'll encounter, but it's good to see a full spectrum of different types there on the right-hand side. These are further broken down in each section as follows: 0 for general, 1 for plans, 2 for elevations, 3 for sections, 4 for large-scale views, 5 for details, 6 for schedules and diagrams, 7 and 8 is left up for the user to decide, and lastly, 3D views and renderings. You'll notice a bit of pattern developing here as you move from 0 to 9. The scale of view from which you are looking at the drawings changes from a macro level, meaning a larger scale overview of the project, things like a site plan and general notes, and you move towards a more micro level, slowly gaining more and more detail as you flip through the pages. This is true for all sets of construction documents, especially for large-scale commercial jobs. So let's talk a little more about each of these types. General pages, usually the first page of the set or the cover page, contain information like project phasing, contractor staging areas, schedules, fencing, photographs, a summary of the codes that need to be followed, symbol legends, and site maps. Here's a closer look. When you hear the word civil, especially in terms of the title civil engineer, civil refers to the shared systems that we all use, and that includes sidewalks, roadways, sewer and catch basin systems, gas lines, electrical utility poles, and the plans that they usually work off of are called site plans. These are large overview drawings that show all of that information listed on the page. Structural drawings, sometimes called the engineer set, labels all of the structural members of a project, including structural steel, concrete columns or piers, engineered lumber sizing and types, and they also show us where each of these pieces can be located throughout the plan. You notice that there are lines that run through this drawing, creating a type of grid. These lines help indicate the exact spacing that structural members must be placed in order to achieve structural stability. The number 1 and 1.5 at the top right portion of the page, those are reference points that will help you identify where on a site a particular structural member is located. So if you were on a site as an inspector and notice a deficiency on one particular column or joist, you would call it out on the plan using the grid to pinpoint which column or joist you were referring to. The structural set and architectural sets share some same information in their drawings, and they usually match a number of floor plans. A floor plan is essentially an overhead view of a building or addition with the roof and upper floors removed. A floor plan shows a location of exterior and interior walls, staircases, doors, windows, pretty much anything you would find inside. A foundation plan shows details about the foundation structure, including foundation walls, slabs, footings, and post supports. And your framing plans will show the details of the drawing's structural members, including roof rafters, trusses, ceiling and floor joists, and support beams and headers. Floor plans, elevations, finishes, building sections, schedules, and details are all part of the architectural set. In reality, floor plans are actually just a section cut, slicing the building horizontally about 3.5 to 4 feet above the floor and looking down. An architectural set is generally where the bulk of all the overall detailed drawings are located. Here's a closer look at the architectural plan. Another part of architectural drawings is the schedules, which include the quantity, material quality, sizing, and location of items that are generally plentiful on a drawing, such as doors, windows, and paint colors, so they are all placed in a chart that can be referenced on any plan, elevation, or section even. This information is really important, but it would take up way too much space on a floor plan themselves to include all of that information. Here we have an electrical plan. It includes power and lighting systems, wiring, fixtures, and devices. All the information that an electrician would need to do their job. A reflected ceiling plan, or RCP, is similar to a floor plan, but instead of a floor plan being cut and looking down towards the ground, the RCP is that same exact cut but looking up towards the ceiling. Here we have a plumbing plan. It includes information like waste and water supply systems, such as hot and cold water layout, sewage disposal, system connections, and riser diagrams. All the information the plumber would need to do their job. You can see a pattern developing here. For those of you taking the plumbing inspection class, you'll be examining these drawings some more, and we'll discuss them later in more detail later in this course. But here is a riser diagram at the bottom of the page, and it details an entire plumbing system in this axonometric style drawing. In this case, we are getting some detailed information about how these all come together, but it's more diagrammatic than precisely where these pieces are installed. Here is a mechanical drawing. It includes information about heating, ventilation, and air conditioning, also known as HVAC. It shows us information like how ductwork is laid out throughout the building, where the supply vents and return vents go, and where the main system unit is located. Just like with any language you learn, there are rules and ways information is composed that makes it the same for everyone to speak and use. A similar system is used in construction drawings, and it's called the Unified Drawing System. In other words, it's a standardization for presenting information. There are 8 modules that break down all aspects of the information and knowledge used in drawing sets, but we're just going to focus on Module 1 today. The discipline designator will define which type of drawing you are referencing, such as the general notes with the letter G, or the architectural set with the letter A. The sheet type designator is the first number that is used to define the first type of drawing within that set. So for architectural sets, A1 would refer to the start of all the floor plans in a set of drawings, and A2 would be the start of the elevations of the architectural set. And the sheet sequence number is then used to count the amount of plans, elevations, or sections you have from each sheet type. So if you have 3 floors on your project, you would have an A-101 for the first floor, A-102 for the second floor, and A-103 for the third floor. Over the next few slides, I'll point this out some more. The Level 1 designator is similar to the list we discussed in the previous slide. You'll notice G is for general, A is for architectural, and so on. Here is where you can add additional disciplines to your first letter designator. Level 1 would not change from the group of letters we saw on the last page, but if that area has highly specific areas, or if you are dealing with a very large project, it may be helpful to break up the plans into more parts so information is more readily accessible to each trade that performs the work on that project. And here we've got the list of sheet types, starting from general, going on to plans, elevations, sections, and so on. This is where the micro or macro to micro level view starts to be incorporated in drawings. Sheet sequencing usually just contains the number of floors or areas you have within your project. But if your plans are revised or your project is broken down into different phases, you'll have additional numbers that end of that sequence that define those more special conditions. So plans on job sites today are mostly just printed from large rolls of plotting paper, but plans have evolved quite a bit. But plans have been made from various different materials, such as vellum and mylar, which were more common when prints were all drawn by hand and using lead and ink pencils, to blueprints, which was one of the earliest ways architects and engineers could make copies and reproduce multiple sets of their designs. But today, all of that is unnecessary due to CAD files. CAD stands for Computer-Aided Design or Documents. This is what almost all architecture and engineer firms use to make their designs and drawings. I'll include a video showing how blueprints like this one shown here are actually made. It'll be located within our Canvas module for you to take a look at. So who uses plans? Plans are used by a lot of different individuals in any given construction project. Architects draw up the building and create the plans that are the guide for how the building will be built, and they also add features such as the style, finishes, types of material to be used, etc. The engineer also draws the building, noting structural details and how the building will be structurally designed. The project manager or site superintendent reads the plans for understanding the flow of the construction process, describes the materials that need to be ordered, gets pricing based on the plans, creates budgets, and estimates total costs and timeline for the construction. And the government building official and plan examiner, they review the plans before they are approved to check for all building codes are met. And if there are any issues, they are marked up, or also called redlined, and sent back to the design professional to make corrections. And this can happen multiple times. The building inspector reads the plans to know what to look for during different phases of construction, and knows what to look for any given inspection. The contractor, foreman, and worker all use the plans to know how to manipulate and configure the materials to construct the building. And the building owner and developer uses the plans to get investors, hold contractors and designers accountable for holding up their end of the contract, and allows them to see the finished product that they are looking for. I'm going to read these the next few slides somewhat quickly because I have a good infographic that helps sum this up in a bit. This is also just a simplified narrative of the process of plan approval. A person buys a piece of property, and that new owner then contacts a licensed design professional, also known as an architect or engineer, to discuss what they would like to have built on that site. Preliminary ideas for the design are made. Once they are narrowed down to that decision, they start developing the construction set of plans. At this time, the owner, architect, or engineer files for a building permit and submits the completed set of plans to be reviewed by the governing agency, also known as the building department. They then review to ensure all the plans meet codes and standards. If there are any errors, they mark them up and send them back for revision. And this can occur multiple times over weeks and even months. Once they are finally corrected, they are pushed through to be approved drawings. At this time, site preparation can begin to lay down the foundation of the building. Construction continues while all types of inspections are being made throughout by the governing agency or the building inspector. They can only progress if they are given approval for certain aspects of the construction, and any issues can hold up a building in many ways and delay the construction timeline. Once the building is completed and all inspections are signed off, the plans are checked to ensure that they match the actual building. If there are any significant changes, the plans are amended to reflect those changes. And if everything then checks out, they are issued a certificate of occupancy, which allows for the building to be inhabited and used for the use it was designed for. Here you can see a better idea of this whole process. It shows the responsibilities of the applicant on the left-hand side and the responsibilities by the building department, in this case LADBS, on the right-hand side. It also shows you what has to be done during plan check, during the permit, and during inspection processes. You can see that there's a lot of back and forth that occurs during this. Let's now take a look at these architectural, electrical, and plumbing symbols. They each have their own unique set of symbols. And material symbols can get a little tricky because they tend to change drastically between plan to elevation to section. We'll cover that more throughout this class. Here are some more examples of symbols and how they look differently on the type of drawing you were looking at. You can see it on the different columns. The first one lists the material name and how that looks in elevation, how it looks in plan, and then how it looks in section. Here are some tips for reading plans. If you're able to visualize and able to interpret, you can go really far with reading plans. The visualization is the ability to create a mental image of the building or project from that set of working plans. And the interpretation is the ability to understand the lines, symbols, dimensions, and notes. Some other tips are to be organized and diligent while reading plans. You want to start like in the upper left-hand corner, just like reading a book, and kind of work your way across the page. Read the plan cover sheet. It contains a lot of project information such as the name of the project, the architect, contact information, project info, date, and sometimes an image of the final product. There are often reference points that are used between professionals and sets of drawings, and they come in forms such as the room numbers, a grid system, and structural references. And review the plan index, which provides a list of all the plan sheets. And this next one should be self-explanatory. You never want to write on plans unless you're authorized to do so. You want to keep the prints clean and protected, so try not to eat, drink near them, don't leave sharp tools on them, and don't leave them in direct sunlight. And when they're not in use, make sure you fold and roll them carefully. Alright, so here's a quick view of the homework for next week. All this will be included in the Canvas shell, so no need to screenshot this or scramble to write this all down. I'll be attaching an editable PDF document that will be attached to the assignment page and for you to use and fill out and for all your answers and resubmit. And that wraps up our first week's lecture. We did a good overview of construction drawings and learned some good fundamentals that we will continue building upon in the next few weeks. Let me know if you have any other questions about the materials, and feel free to email me or send me a message on Canvas.